Hi guys, today I'll be solving a LeetCode problem, which is the maximum path sum. So what we have to do is, for example, we are given this tree, so we have to find the maximum path sum. So what are paths? What are the paths that we can draw in this tree? So these are the paths that we can draw. For example, 9 to minus 10 to 20 and 25 to 15. That is one path. So the sum of this path is 34, and this it is 26, and this for it is 42. So this is the result that we need to give. The result, okay? This is the result that's going to be, right? And how we have to solve this problem. So you can pause the video and think of the approach, and then you can come back. So you have paused the video. So now I will go with you. I will explain you how the solution we are trying to build the solution. So what we are seeing in this pattern is that there is an anchor point, right? There is this U type of thingy, right? This is the U thing. Okay. So we are going to use this U thingy. So what is happening is that actually we are trying to find the left sum of this part and the right sum of this part, right? For example, this is the 10. This is 10, okay? So what is this? This is the right sum of this. Okay, this is the right sum. Okay, this is the right sum. Yeah, sorry. This is the right sum. And this is the left sum. Okay, that is one thing. Yes. So now what we are going to do is first we are going to find the maximum path on the left, okay, and the maximum path on the right. And then what we are going to return the path, the maximum sum, okay, the maximum sum that can be generated if we consider this node as an anchor point. So that will be actually the sum will be sum is equal to, it will be the left part, sorry, it will be the node plus the left part plus the right part, right? This will be the solution. Yes. So that can be the maximum sum. So now first let's think of that approach, how we are going to figure it out. So first let me draw that tree again. So minus 10 we have, and we have 9 here at this position. We have 20, we have 17, and we have 5, right? So let's just think, what if I had the left sum of the root? So let's say magically that L sum is equal to um like find sum, okay? Find sum root dot left and L R sum, find sum root dot right. Okay, just in case, just assume that magically we have got this. So what we can return is, what we can do is, we can keep a max variable, okay, max variable, which will keep a track on the sums that we're finding. So what I mean by that is, for example, if I have given an array, if I'm given an array and I have some values in this array, 3, 4, 1, 2, 5, right? So if I want to find the maximum in this array, what we have to do? We'll have to iterate this complete array, right? And then I can check the maximum. So what I will do is, I can put maximum as minus infinity or like 0, it doesn't matter. If I put maximum as minus infinity, then I will start from the first element. So I will compare 3 and minus infinity. Well, obviously 3 is greater. So I'll change it 3, change 3, and I will go to 4. I will check 4 is greater than 3. So obviously I will update it 4. And I will iterate again and I will check 1. Is 1 greater than 4? No. I'll go back. I'll go again. 2. Is 2 greater than 4? No. 5. Is 5 greater than 4? Yes, it is. So it will be 5, right? And this is done. That's how you find the max. So this is the same logic that we are going to try to implement in this, okay, in this question. So let's assume, how are we going to find the maximum sum? Okay, let's say this left part has only one node, so you know for sure the left maximum sum. Okay, these are the max sum. That is a very important thing to consider, and how we are going to get it, I will tell you simply. One thing you know for sure is, I'll just write that part. Okay, 1 second. Sorry. One thing you know is like, if we reach a null point, then we can simply return 0, right? Yeah, yes, we can simply return 0. Now This is actually the maximum left sum, and this is the maximum right sum. Okay. So what I mean by that is now, for example, I start from the root node -10. Then I will try to find the first left maximum sum. So I go to 9. Then if I go to 9, then 9. So for example, I'm waiting for L sum to be calculated. Right? So I've come to 9. So 9 is also going to calculate its L sum. So what it is going to go for null, obviously, because 9's left is null. So on that, it is going to return 0. Then right also, it's going to return 0. Right? So now, what should I return? What should I return so that I can get the sum to -10? I can say return node, this node. What is this node? Return root value. Yep, that is the node itself. So I will return 9. I will return 9. So now where I will go is, I'll go to the right part, because now I have to find the right sum. The left sum of 10 has been calculated. Now I will have to go to the R sum part. I'll go to the R sum. For R sum, okay, R sum, left sum is calculated, which is 9. Now I have to find the R sum of 10. I'll come to 20. So obviously for 20 also we have to calculate L sum. For that 70 will go. Then we'll go to this cross. We'll check this also, and we'll check this also. We'll both are going to give 0. So this 17 is going to be returned. If 17 is returned, then we get L sum as 17. And similarly, R sum is also going to be obtained by 5. Obtained as 5, right? Now, what were we returning? What were we returning? We were returning root.val. So here what we are going to return 20. Really? Is 20 the sum? Do you think so? No. What is the sum? Actually, we can return, we have to also include the left and right part of it. So how are we going to do that? So should I include 17 or should I include 5? Remember, we have to return the max. How are you going to get the max? Simple. You can do is L sum, R sum. Simple. So L sum is this. So this is going to be returned. This is going to be max. This will be selected, right? And then with 20, 17 will be written. Oh, my bad. I think I didn't copy it. 15 and 7. Sorry. 15 and 7. 15 and 7. This is the part, right? So 15 will be returned. Now what we are returning is roots val plus maximum of L7, L sum or R sum. So this is 7. Now what we are going to return is 20 plus 15. R sum is actually 35. So once we have calculated L sum and R sum, then what we are going to return here is, let me erase these things. What we are going to return here is, this will be returned val, so -10, this maximum of L sum or R sum, which is R sum is 35, going to be returned as 25, right? So yeah, 1 second. 35. Yeah. So this is one analogy. Now what we have to think is, did we trace? Did we like kept a max variable which was checking the values? No, we didn't. So we should also do that. So where are we going to do that? Actually, we are going to do this here. Max, let's say max s, max sum. That is the maximum of max itself, max s. We can compare that. And here we are going to use this root.val plus L sum and plus R sum. That is the code. Let me give, let me. So let's again iterate this. So this is the part, find sum. This is the algorithm. Find some root. my bad. 1 second, just have to check it. Yeah, it's recording. So I'm here. Now we had to keep a max variable. So let's again traverse this uh, tree so that we will be able to find the value again. So we had minus 10, right? Then we had this as we had minus 10, we had 9, then we had 20, we had 15, we had 7. That's it. So we had. So let's start with 10. So we start with 10. For 10, we have to find the LCM. For LCM, what we need, we have to go to 9. We have gone to 9. So for 9 also, we have to find the LCM, which is going to be 0. You know why? Because 9 will call null. That is going to return 0. This also 9 is going to call null. It's also going to return 0. So now what we have to return is value plus maximum of LCM or RSUM. So 9 plus 0 will be returned. So we have found the, yeah, and one more thing. Before returning, we also have to make this call. Right now, max s was minus infinity. Now it will be updated with the new value, which will be 9, right? Yes. LSUM will be returned 9. Then we have to call for the RSUM. For RSUM, we have to go to the right tree. So when we reach the right tree, then we'll have to go for LSUM. So we'll find LSUM. LSUM will go to this node. So this node will also call for null and null. So null and null will return 0 and 0. Now we will compare max with this value, as we have to compare it with 9 will be compared with 15 plus 0 plus 0. So obviously 15 is big, 15 is larger. So 15 will be updated with the new max's value will be 15. Yes. So now this 15 will be returned. LSUM will be 15. So now for finding the RSUM, we will have to go to the right node, right part of the tree. So let's go to the right part of the tree. This is also going to make a null call. This is also going to make a null call. We are going to return 0. LSUM will be 0 for 7, 0, and RSUM will also be 0 for 7. We will compare 15 with 7. Is 15 greater than 7? No. Sorry, is 7 greater than 15? No. So this max will not be updated. So now RSUM will also be calculated, and that will be 7. So LSUM and RSUM has been calculated. So for getting the minus 10 RSUM value of the root node, we are going to return. But before returning, we are also going to compare the values. So now 15 will be compared with 20, that's the root's value, root.val, plus LSUM of 20, which is 15, plus RSUM of this is L, this is R. So what is this value? This is 42. 42 greater than 15. Yes, 42 will be the new value. 42 will be the new value, and we are going to return 42 here. So 42. Now we are going to find this part. We are also going to find for the root node. So now 42 will be compared with what? Root's value, which is minus 10, which is root.val, and then LSUM, which is 9, plus RSUM, which is 10, which is 42. So this is minus 1, and we have, yeah, one thing. Yeah, so I'm back. Here, what will happen is that 42 is going to be called. So is 41 greater than 42? Which is not. So this is going to be, this is how we solve this question.